All right, today we're going to continue factoring, and you're going to be factoring perfect square trinomials. Now, these are actually fairly simple to factor if you can recognize perfect squares. And here's what you're looking for. If you're asked to factor something like 4x squared minus 24x plus 36. If a trinomial is written in this form, and the first term, the 4x squared, is a perfect square, and the last term is a perfect square, then the shortcut is to find the square root of the first term. So the square root of 4x squared is equal to 2x. The square root of 36 is equal to 3. No, it's equal to 6. Now, since the middle term is negative and the last term is positive, when you factor this, it's 2x minus 6 squared. The square root of the first term goes right here. If the middle term is minus, then this is minus. The square root of the last term goes right here. And you just finish with parentheses and raise it to the second power. Make sense? So then if you had 64x squared minus 16x plus 1. $64 is a perfect square, isn't it? 1 is a perfect square. Agreed? So what's the square root of 64x squared? 8x. The middle term's minus, so what's this? Minus. What's the square root of 1? 1. Close your parentheses and add the exponent. Thank you. If you get something like 81 z squared plus 36 z plus 4, same rule. Square root of the first term, what's the square root of 81 z squared? 9z. If the middle term is positive, then what's this sign? Positive. Square root of 4, 2, add the exponent. Everybody okay with that?
Yes, sir.
All right, then the last thing you're going to factor is the difference of two squares. And that's something like a squared minus b squared. If you had to factor a squared minus b squared, they're both perfect squares, and they have a subtraction sign in between them. This would factor to a plus b times a minus b. All right, and if you look at the first term in each of the factors, isn't it the square root of this first term? What's the square root of a squared? A, so you got an a here and you've got an a here. What's the square root of the b squared? B, so you've got a b here and a b here. And if there's no middle term and this is subtraction, then you just go with a plus and a minus. Because when you did the distributive property, okay, a times a would be a squared, and a times negative b would be negative ab. B times a would be positive ab, and b times negative b would be negative b squared. And negative ab plus ab would cancel out to a 0, so you'd be left with a squared minus b squared, which is what you started with. So the same holds true when these a, or when this a and this b are perfect squares, with, again, no middle term. So 25x squared minus 49. You got no middle term, so understand you're going to have two factors. The square root of the first term, what's the square root of 25x squared? 5x. No middle term, right? And another perfect square, so it's plus and minus. Square root of 49? 7, 7. You're done. (16x squared) minus 121. All right, again, no middle term and two perfect squares. So you got two factors. The square root of 16x squared will be the first term in the factors, so that's 4x and 4x. No middle term with perfect squares, so plus and minus. Square root of 121, 11. Now again, make sure you realize and understand that this only works when it's subtraction, okay? If you got two perfect squares and there's a plus sign in between them, oh, 4x squared plus 64. In this case, all right, you can only factor out the 4. All right, you're not going to get two binomials out of that because you have a plus sign in between. So in this case, we would just factor out a 4, and you would have x squared plus 16. So if there's a plus between the two perfect squares, just try to take out the GCF. You can't factor it into two binomials. Questions? All right, your practice is going to be on page 221, 47 through 55, and 10 ALEKS topics again. If you haven't been here or listening for the last 13 weeks, ALEKS topics are due on Fridays. ALEKS topics, the calendar runs from Saturdays to Fridays. Okay, so your 10 ALEKS topics are due this Friday. Everybody understand that? Very good, very good. All right, get to work then, please. What? Not till you finish your assignment.